So here I have the problem. I've set up some variables to storing the initial Alice's miles per gallon, Bob's miles per gallon, and Cindy's miles per gallon as 10, 20, and 40 miles per gallon. Now we're going to invert the MPG's miles per gallon. So we have this. Then we take the sum of those and we divide by 3, or the total number, and we get gallons per mile. So this is the mean GPM. And then if we do 1 divided by mean GPM, we get 17. So that's with the first method. The second method is we get the total miles they all drive, which is 3,000. Then we get the total number of gallons each one uses while they're driving. So Alice uses 100 gallons to drive 1,000 miles. Bob uses 50 gallons to drive 1,000 miles at 20 miles per gallon, and Cindy uses 25 gallons of gas to drive 1,000 miles at 40 miles per gallon. So then we get the total gallons used. So we have 175 gallons of gas between all three of them. Then we get the average MPG by dividing. So this is just multiplying by 1 here to turn this into numeric output. So we get the total miles driven. So that's the average MPG. Actually, wait. 17. So you see this answer and this answer both match. So now we have a new scenario where they increase their mileage, and we want to find out what the difference is. So I've created a interactive plot here where you can change how many miles in a display. Here we have MPG on the bottom. So say you want to look at, you can set it to 1,000. So you can say I want to look at a plot where each person travels 1,000 miles, how many gallons of gas they need to use. So say you have 10 gallons, it would take 100 10 MPG, it would take 100 gallons. Now Cindy goes from 40 to 55, and we're looking for the difference between these two values. For Bob and Alice, we're looking for between 10 and 13, so that would be around here. And then Bob goes from 20 to around 28, so we want to find the biggest difference. This gives an expression for the total number of gallons. So using the first method, we can make some variables for new MPG. So Alice, so you can just do new MPG equals 13, 28, 55. And then we will do new MPG minus, so we set MPG to Alice MPG. So we get the difference between, so we see those are the differences, and then we invert that. So we do 1,000 divided by so we see that the difference in so you have 1,000 miles divided by this many gallons, and it looks like Alice saves the most in terms of miles. So she gets 333 miles because before she was only able to get 100 miles. She needed 100 gallons of gas, and now she needs this is just taking the first part. So she has an increase of, actually, wait, So it looks like it's negative, so we can change the order. So Alice saves 23, Bob saves 14 gallons, and Cindy saves 6 gallons. So now we need to solve for how much they each need to save to, so we can add to, we can solve for, take the first element of gasoline saved, which is 23, and solve for Bob. I'm just getting the numerical value here. So it looks like Bob's new MPG would need to be 37, and we can do the same with Cindy to see how much her MPG would need to increase. Change the variable name there. So apparently Cindy would need to up her mileage per gallon to 5,000. So let's just check that. So Cindy, so 25, it takes her 25 gallons of gas. And if we add the increase, I mean, if we subtract the increase, so Alice saved 23 gallons of gas. That's the difference between her inefficient car and her new efficient car. So she saved 23. So we subtract 23 from Cindy's amount of gasoline. So we get, and then we solve that for Cindy MPG times 1.92. And we get something very close, 520. So Cindy would need to have a mileage per gallon of 520 to match the increase. Now, if we go back up here, I think I'm running out of time, so I'm going to cut it short.